Okay, so this is one of the variations on the Incredible Hulk. I mean, incredible, angry, good-hearted, green-skinned man. Um, ooh, that's just better. You know, Marvel's gonna come get me. Here we go. Incredible, uh, angry man. There, that's better. Okay, just ignore that first part of the video. Okay, so next. Here's the question. The incredible, angry, good-hearted, green-skinned man plucks a kitten from a tree and lowers it to the ground safely. Aw. So, A. In your written work, draw a free body diagram of the kitten during the rescue. Here, list the forces acting on the kitten. Okay, well, here's the cat. Here's... Oh man, the art skills. So good. Here we go. Kitten. Right. What's going on with its back end? Okay, that's as close as I can get. I'm sorry. All right, there's our kitten. And what we want to do is indicate the forces acting on it. And I'm not too specific here, but the way that I phrased it, I'm really trying to keep you from thinking that he like lifts it up first and then down. He's just like grabbing it and then moving it downwards. And so I'm not too particular on the size of these forces, but basically there's just going to be the force of gravity down, okay? And there's going to be some force from the dude, the man, okay, upwards. You can call that a normal force because it would be the normal force of like his hand acting on the kitten. And if the kitten is moving with like a constant velocity, so no acceleration, then you'd expect these two things to be equal and opposite. But otherwise, maybe a small downward acceleration, something like that. Okay, not too particular here. All right. There's nothing else touching the kitten, by the way, so those are the only forces acting. Is the work done by each force in your diagram positive, negative, or zero? Please briefly explain your answers. Okay, so in terms of the force from the man, well, this is going to be doing, if the kitten is moving downwards, right? So displacement is downwards during this whole process. Well, then the work done by the man is going to be the force done by the man times the displacement times the cosine of the angle between those two things. Now, we don't know what the magnitude of these two things are, but we know their directions. One of them is up, one of them is down. So this theta is equal to 180 degrees, and so this is going to be a negative number, whatever it is, okay? Because the force of the man is working against the motion of the kitten. And in terms of how that makes sense, well, imagine if that force wasn't there. Well, the kitten would start accelerating quite rapidly, right? So we are tending to remove energy from the kitten by supporting it with, or the man is, with his hand, right? That's the idea. And it would have more kinetic energy, in other words, if this force wasn't here. Okay, now in terms of force of gravity, same idea, except the angle between the two is 0 degrees because they're both pointed straight down. And so this whole thing will be a positive number. Force of gravity is acting in concert with the displacement of the kitten, and so we'll be doing positive work on the kitten, adding to its energy. If the velocity of the kitten during the rescue is constant, what is the net work done on the kitten? All right, well, you could go about this a couple of different ways, but by at least a little bit, the shortest thing is to say, okay, well, V is constant. That means acceleration is 0, and that means that the net force has to be equal to 0. Actually, this is a long way, okay? And then you could go through the definitions of work and determine that those two those two works had to be the same number, but one with a negative sign and one with a positive sign. The shortest method, though, where I meant to be going there, is to just apply the first version of the work energy theorem that we saw, right? KE for those of you in Physics 100. Okay. If you have a constant velocity, then the final kinetic energy is going to be equal to the initial kinetic energy. And so this whole thing has to be 0. Okay. And that is equal to the net work done. Lastly, part D. Which, if any, of the forces acting on the kitten is non-conservative? Okay, well, we only have one conservative force that we've studied in this class, which is the force of gravity, so that's out. And we've been told, and I have told you, and you have read, and all these lessons, right, have said that all the other forces are non-conservative. And that means that the force due to the angry man is non-conservative. Non-conservative. And there we go. Okay, that's it.